Hello, everyone. Sorry for the late start. I hope everyone's having a great re:Invent. My name is Daniel Valdivia. I'm an engineer here at MinIO. I'm responsible for Kubernetes integrations and AI and ML initiatives. And I work for MinIO. And for those of you who don't know what MinIO is a high-performance software-defined object store built for scale and speed, right? So we are, in the open source community, we are pretty much one of the most popular storage solutions out there with deployments and pools all over the world. So that is who I am, and that is what MinIO is. So let's get started with the premise of the talk that I'm trying to walk you through today, and the solutions and the problems that we're seeing and the solutions that we're actually proposing, right? So here, starting with the three basic problems at hand. The first one is that the petabyte is becoming very quickly the new terabyte, right? The petabyte's been commoditized because, like, just a few years back, you see everyone deploying and doing analytics on terabyte-size data sets and analytics on top of unstructured data. But very quickly, recently, we are seeing customers now no longer deploying or thinking in terms of their data in terms of terabytes. They're actually all going to petabyte scale. So very quickly, the petabyte's being commoditized, and it's becoming in the common lingo. Now we have a petabyte of data, 5 petabytes of data, 10 petabytes of data. Things keeps going, and this actually stresses the older systems that were designed for moving a few gigabytes of data. The terabyte was kind of like an exception, but now petabytes here. Just this year, we're starting to see exabyte conversations coming more and more often. So this is taking a big toll on the systems. We're at the point where the conversation about moving petabytes of data is actually becoming harder. Just as a reference, a single snowball is 1.6 petabytes in capacity, and that's only how much data you can move on a single snowball, for example. So now when you actually have deployments that are like larger than 1 or 2 petabytes, you actually start thinking, okay, now you're actually probably going to need the snowmobile, right, to move that much of my data. So the next part of the problem is that most of the data is actually distributed. It's actually being generated all over the place. In general, every day we're generating 326 exabytes of data all over the place, right? And every single enterprise, well, not every single enterprise, but most enterprises have multiple cloud providers that they're leveraging, either public private providers, about 3.4 or 3.9 private. And that's actually making that the data is actually now sparse. It's in multiple different places, and it's hard to consolidate it to one. And lastly is that it's a reminder that the cloud is how, not aware, right? So the cloud is actually an operational model, and that is the right way to be leveraging the cloud, because we see most of the modern challenges when it comes to AI workloads, that the accelerators are changing at a rapid pace. Right now, there's a strong dominance by a single provider of accelerators, or GPUs for that matter. But very quickly, you see the likes of AMD, Intel, Amazon coming on with their own accelerators. Just this meeting, we just saw the new Trainium 2 announced. It's a beast, and I don't know if you guys have stopped to see the new machines they have on display. They're amazing. But pretty much, if you were trying to build on top of like static infrastructure, and these accelerators tend to be expensive, it's not something that you can pretty much have in a static fashion. So it's something that you should be leveraging, but you are only allowed to do this if you actually take ownership and control of your data. So the advantage of how the transitioning of the industry has come over the past 3 years, where everyone's containerizing their workloads, everyone's going cloud native. Now everyone's going cloud, it's software defined. Now that actually gives you the tools you need to actually start thinking about how to modernize your AI workloads infrastructure in a way that's portable. So this is where the concept of burstable workloads starts coming into place, right? So I was introducing you to the problem of accelerators. And the first part of the problem is, the first problem of the concepts to introduce to burstable workloads is about compute is ephemeral. So compute is traditionally something that you need elastic. You need to train. You need your production to be elastic because you don't know how your business use cases are going to be probing. Or if you're running analytic workloads, you definitely need compute sometimes more. Sometimes you need less compute. when you're training AI machine learning algorithms, you definitely need the compute when you need it, but when you're done training, it doesn't make sense to have those GPUs sitting there idle. GPU is one of the most expensive type of machines you can actually request right now. So but the advantage is that these are ephemeral. So if you actually architect your infrastructure, your AI workloads so that you can actually just allocate the compute when you need it. And you keep the data in one single place. One single place that's predictable, it's protected, and it's compliant. It's way easier to start just leveraging elastic compute on top of AWS, for example, right? So the type of workload matters. Like I was already mentioning that production workloads, production workloads are harder to keep in one place. Sometimes production can be even 0 if you're already leveraging Lambda. And most of the AI workloads, it comes on demand, right? So you have enough data to start training now. And you definitely need to start a training session. So now you need to start allocating your GPUs. And then you need to start training everything. So AI workloads and analytic workloads, type of workloads, allow themselves to this kind of I need it now, I need to crank it down, crunch it, and when I'm done, I can actually tear down all the infrastructure and be ready, right? And the best part is that you can scale in any direction, right? So the main advantage of actually architecting your AI workloads in a way that data and compute are decoupled is that if yesterday you were using some GPUs and today you saw the training 2 machines and you want to leverage those, it's even easier, right? So if you already have a properly designed architecture that allows you to burst to the cloud. So when I say burst to the cloud, what am I talking about? How is someone supposed to be leveraging this? So let's start with the step 1. So this is where MinIO can come handy into place. MinIO being a software-defined object store that's 100% compatible with Amazon S3. You can actually start consolidating your data in one place. And why would you do this? First, let's say you may have some compliance reasons, some governance reasons. Your data is so precious it cannot be anywhere, right? For a variety of reasons. Or you're generating the data in multiple places and you need to consolidate in one place. And also, this is the most important aspect of data. Data, you cannot scale data to 0. You cannot scale data to 0 bytes, and then next day you want to scale it back to whatever you had. You definitely need to keep the data. Data is something that just keeps growing at a predictable rate. So yeah, you can prepare for that. But then, when you actually have the need to start actually crunching the data, this is where the problem comes, and this is the right way, in my opinion, to actually start leveraging the cloud. That's when you need to start actually crunching the data. This is where you actually, okay, I'll start spinning up my accelerators from one place to another. In AWS, I'll spin up all the GPU instances. When I was making this slide, training wasn't announced, so I will have just training here, but I start spinning up my GPUs because this is now what I needed. I'm about to start training. And what about the data? The first thing that comes to everyone's mind when I mentioned it, everyone's going to be like, there's going to be latency. I'm going to be pulling the data. It's going to be slow because my link in my data center or in whatever I'm keeping the data is not as fast as within AWS. But this is where you can, the advantage of MinIO being software defined also allows you to even set up an edge MinIO and stashing the data. And we're already seeing this in a lot of our customers. They actually create a temporal MinIO location where they actually preload the data. And pretty much now that this means that the data only travels one over the wire. Now the infrastructure gets started training. And because it's local to the cloud provider, it's fast. Now, this is the second step. And the third step is pretty much simple. Poof, right? You're done training, you save your storage engine, and then you report back to on-premise. And then all the capacity that you have for training, the expensive resources can actually be eliminated. And this gives you the dynamism that when you need it, you use it, and when you don't need it, you can actually turn it off. And this goes back to the very first point that I was talking at the beginning of the presentation, which is the cloud is not a place, right? It's an operating model. And if you actually are architecting your models to actually leverage the cloud in this way, things actually become quite trivial. So, but yeah. All right. So why MinIO and AWS are such a perfect fit? To begin with, MinIO is modeled after Amazon S3. Amazon did, for those of you who don't know, but when Amazon launched Amazon Web Services in 2006, even before EC2, even before EBS, there was simple storage service. There was S3. Amazon understood that to consume storage, you needed to do it over the internet over a simplified API, no POSIX baggage, and they got it right, and they should get a lot of credit for that. So, but for all the data that needs to exist outside of Amazon, that's where MinIO comes into place. And the advantage of MinIO being 100% compatible with Amazon S3 is that you can actually have all your workloads working on AWS and on-premise, not a single change not a single line of code change needed, right? So the advantage of also having all of this is using all the same technologies all the time. You don't have to worry yourself that I'm not advocating for you to adopt any proprietary tool in this case, or anything that's not standard. I'm not vendor locking you in. So pretty much the main advantage of having total compatibility is that it allows you to do these kind of strategies where you can actually be smart about how you run your operations. And yeah, I think this is all good from this slide. And lastly, the key considerations, or the one that make the things work from my presentation, are the three key parts are the edge MinIO, right? The advantage of software-defined MinIO is that you can actually you can actually plan for this by using CloudFormation, for example, provisioning your edge MinIO, pulling the data sets that you're going to be using for either analytics or training, setting up the GPUs, starting the training. When it's done, backing everything up, tearing everything down. It can all be done simply, right? No need to have someone babysitting the process at all. It's something that can be entirely automated. So the data transfer only happens once, and once you're done, you actually destroy the edge MinIO. So there's no trace of the data on the cloud. So if you have some compliance requirements where the data needs to be living on a single place, that's also taken care of. And of course, all of this can happen in a very secure fashion. So data can be encrypted in transport and at rest by actually leveraging either AWS KMS or MinIO KMS, where all the data that's on the edge MinIO while it's been trained is actually properly safeguarded. So yeah, I'm about to run out of time, so I don't think I'll have enough time for a demo. So I'm going to skip that part and go straight to the relevant conclusion, because I don't know if we actually have time for questions. I'm not pretty sure, but if you guys have any questions, we can definitely take one. But yes, the main idea here is about controlling cost. Again, in the age of AI, you rapidly see the demand for compute growing, and that's mainly driving cost. So being smart about how you actually prepare your training infrastructure is crucial, but on the same part, data is exploding in size. So taking ownership of your data, which is your most valuable asset, is key in all of this conversation that I'm having with you guys, and very important. So also protect your data. This approach doesn't create any security gaps. You're not having to scatter the data all over the place, have to understand different security models from different cloud vendors if you are actually generating in that way. You only have one place to protect. You institutionalize flexibility, right? You're teaching your developers this is how you design the workloads so they can actually be run at any given time. And well, yeah, you are always able to run the latest. Just I was mentioning all along the talk how excited I am for training too. Like if you were training on top of NVIDIA GPUs, and tomorrow, I mean, you already can leverage Gaudi on AWS today, but you might want to leverage or test AMD MI300X or the training to hardware. That flexibility is the grace, and this is the type of flexibility that only AWS can offer you, right? Only AWS can actually take the risk of acquiring this latest hardware and letting you leverage it, so you don't have to acquire it. But the data, again, being the most important asset, that's the only part that you have to take care of. But yeah, all right. So I think that has been my lightning talk. Sorry, I was kind of late. I was running all over the place. But yeah, I don't know if we can actually have questions. No one told me about that. But if anyone has any questions, we can probably take them in the 2 minutes that we have left.